In some situations, when a quantity varies directly as another quantity, at the same time, it also varies directly as some other quantity. We can actually put these two relationships into one. In this case, mathematically, we could say A equals to K1B. At the same time, A also equals to K2 times C, where K1 and K2 could be two different constants, non-zero constants. We could put them into this equation. A equals to K times B times C, where K is a non-zero constant. If I hold K, B as constant, then you can very quickly see that A varies directly as C. And for some particular value fixed at B and with K, KB together would be your K2, right? And likewise, if I fix C as some particular value, KC would just be the K1, the non-zero constant. And so at that case, A varies directly as B. And this is what we call the joint variation. That is a relationship between three or more quantities. And of course, it could be in some other forms, not necessarily a direct variation with two other quantities. For example, A could vary directly with one number, but inversely with another one. It could be inversely related to two other things, or even more quantities. Now let's check out this example that sums up all what we need to know for joint variation. Okay, so it's given that S varies directly as M and inversely as the cubic root of N. And N must be greater than 0. When M equals to 3 and N equals to 64, S equals to 9 over 4. So part A, express S in terms of M and N. So standard protocol. All you need to do is just follow these three steps. Because M is a direct variation, so I put this on the numerator, and because this one is an inverse variation, so I put this on the denominator. And of course you need to say K is a non-zero constant. Now next step is I need to substitute this initial set of numbers. Now we have three values together, and I got K equals 3. And here's the answer, the complete equation. When M equals to 5 and N equals to 125, S equals to this. We just substitute the two of the three and we find the last one, right? But don't make a careless mistake. Don't mistaken these numbers with these, okay? Because these three are teammates. They are one team. They are together, okay? They don't match with these, all right? So don't mix it up. So the last kind of question, okay, of course, is the percentage problem, okay? So M increases by 20% and N decreases by 48.8%. Find the percentage change in S. So again, we need to list out that table for our own sake. So of course, we want to find the percentage change in S. Make sure S is the subject. So we're fine here, okay? So just like before, except we have to make initial values for M and N respectively, okay? This is the starting point. And using this information and this information, we got the new values for M and N in terms of the old value. So what about S? I just put the original numbers here like that, and for the new one it's also in this format, okay, except the M1 is the new M value, right? And so is the new N value, right? And of course, this table is for our own work, okay? When we answer the question, we need to answer these, right? Here's the new value for S, and I'm gonna write it here. And then we move on to the percentage change, which equals to the new S minus old S over the old S. Okay, then there's a lot of common factors to take out. Almost all the time, your variables will become the common factors that could be cancelled. Okay, and so the answer would be plus 50%.